I think the analysts now are, all predicting that the greatest use of that environment will be in industry. It is the ultimate use of data at scale to help companies and countries make better decisions.
Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to be here in the Manchester studio in the Siemens Manchester office. I'm joined by Brian Holliday. He is the Managing Director for Siemens Digital Industries in the UK. So welcome, Brian. Thank you for joining us today.
Thank you. Thanks for having me.
And before we sort of go into our topics today, I know we're going to cover sort of a broad range of topics related to digital transformation, both for sort of SMEs all the way through sort of enterprise. But before we start, I guess it'd be great for the audience just to know a bit about your background and your role at Siemens. And that'd be great.
Oh, certainly. Prior to joining Siemens, I was an apprentice with Texas Instruments, a computer systems apprentice, and joined Siemens as a graduate. And I've had the pleasure of working in computing, communications, control, mainly control systems over the last 30 plus years. But the pleasure of working at Siemens has been through, really so much customer contact, companies, small companies through to larger ones, really solving industry specific and manufacturing specific challenges. And I guess by way of background, I've had the pleasure, the privilege of being able to contribute to, a number of extracurricular activities. I've served as a governor at a university technical college. I've been on the board of Make UK, the manufacturers organisation, over the last 9.5 years, and I've served on the board of the High Value Manufacturing Catapult, for example, as well. So I've really enjoyed my role at Siemens to be able to to work closely with companies adopting technology, but also to work with, government and policymakers in this space to perhaps help advise on ways in which we can improve, and we do need to.
And you mentioned, Brian, obviously many years of experience. We don't need to name the number exactly, but many years of experience, lots of different roles. So I'm just wondering how, with all those different experiences, how have you brought that into your role within Siemens today and what you're doing today?
I guess there's accumulated experiences like everyone. I guess what that's done for me is it's helped me to grow a passion for technology and for people. Ultimately, technology is a people business. People need to understand what technology is, how to deploy it, and if I've been able in any way to play a role working with companies and, as I've mentioned, policymakers to understand the potential benefits. I guess that's been the centre point of what I've been doing over the last few years. And that's been interesting, exciting, intellectually, stretching because of the sheer pace of change. Yeah. But there's something about industry that, of course, is so incredibly tangible, designing things, making things, doing that better. And there's a global context for that conversation because, of course, manufacturing matters. So I think that passion's accumulated into something that I would get up in the morning every day and do, whether I was working for Siemens or not, I think.
No, exactly. And I guess let's open up the topic straight away. So in terms of challenges manufacturers are facing at the moment, and we could talk about it in relation to adopting digital technologies, but maybe we could start more broader than that and then maybe zoom in on the digital part as well. So let's start with the challenges or manufacturers are facing in 2025 as we are now.
What I consistently hear is that manufacturers are struggling with skills. It's the availability of people. And whilst the UK has seen an acute shortage of people, related perhaps, to Brexit to some extent in manufacturing, but to people leaving the workforce after the pandemic, that there's been a shortage of people. And in particular, we struggled with the shortage of people who've got the right sort of technical skills to help us in the adoption and deployment of technology. But the knowledge of what technology is and what it can do is a critical component here as well. And it's a really important conversation to have because, the Made Smarter report that I was part of identified our under-adoption of industrial technology here in the UK, and it found a correlation between that and productivity. So many of us know, and it's been speculated on in the media, of course, that productivity flatlined in about 2008. It didn't continue to improve. And so I think that there's a link between technology and productivity. There's a link, as we found in the supply chain crises, the sort of post-pandemic supply chain crises that firms were faced with as well, that technology equally became part of the answer. And then there's sustainability, that we're to try and be more sustainable in what we make, what we consume. And again, firms have to balance the cost of being sustainable with clearly doing the right thing. So, these headlines of skills, of technology, of resilience, of sustainability are all underpinned by access to finance as well. And firms report a range of these challenges that they face all the time. And so I think, there are some very interesting conversations to be had about unlocking value. And I believe technology plays an absolutely fundamental, a central role in addressing the sort of challenges that industry and industrial infrastructure faces.
And in terms of the adoption of technology, is it something, because you name a lot of different areas there, is it sometimes that, people are busy and they've got lots of priorities, lots to think about? Is it hard to sort of prioritise, where do I start first? Do I focus on sustainability? Do I focus on a different area? Is that part of the sort of the problem you see?
It's absolutely part of the problem. Firms see business challenges, they see operational challenges that they face. And whilst we talk about the concepts of Industry 4.0, and a digital revolution, that's predicated on the first having been, mechanisation, the second electrification, the third automation, and this idea that we're to use data and it's going to unlock value and productivity. Firms don't necessarily know what to do with that or where to start. They have a sense that tech can help. But my experience from seeing a range of smaller firms that have benefited from working with the Made Smarter adoption program is often that they're operating on a day-to-day basis without necessarily a vision, a strategy, a budget, to finance tech adoption. In larger firms, it depends on where they are. They may have a maturity cycle, but I guess we've got to not think of technology for technology's sake. We've got to think of business problems that we're trying to solve. And I think what's helpful in both contexts, small firms, large firms, are stories about where technology has made a difference. Where it can impact the value of the firm to make companies fundamentally more productive, more competitive, and more resilient. But underpinning all of that, of course, we've got the new imperative, the very clear imperative, is we've got to use technology to become more sustainable.
Yeah, and you've mentioned it a couple of times now, but the Made Smarter Commission. I mean, maybe first of all, I guess first question is to people who don't know, what is Made Smarter? What it's looking to achieve and who's involved. But I guess more importantly, how is it helping to businesses to embrace digitalisation, and accelerate that in their organisation?
It was a 2017 report. It was government, academia, the business representative organisations and industry. And I had the pleasure of working with a broad range of stakeholders at the time on the report itself. Greg Clark, the Minister for Business at the time, was our sponsor. But it did under-leveraged technology, under-leveraged innovation, skills that were not where they needed to be for us to make good use of tech in manufacturing. And it identified the opportunity as about £455 billion of contribution to GDP over the following 10 years, 175,000 net new jobs, a 4.5% reduction in CO2 output, which I think actually looks modest now. But it resulted in the funding of a technology adoption and a technology innovation program with government that today has stood that test of time and still returns, for every pound of public money spent, £7 to the economy, because companies that get engaged in, the leadership and transformation programs, the digital technology workshops, in the grant funding that helps them get going with an innovative investment, Made Smarter has made a huge difference to the long tail of small firms that make up our manufacturing sector. And, that starts an innovation journey in my experience, where they go on to think about, the skills they need, the finance they need, the technology, where they can start to improve on a more regular and structured basis.
And what's really interesting for me, at the heart of all that, there's one word that springs to mind. It's collaboration. And the most impressive thing is bringing government, and it's bringing together industry, together to solve problems. So how important to you is that, and Siemens as a whole, let's say, as well, in terms of bringing in different companies, organisations, technology companies together to come to these solutions, because we can't do it on our own, right?
No, and even a big firm, people might assume, well, Siemens is huge.
Yeah.
Over 300,000 people and significant R&D resources. But no, we increasingly talk about ecosystems. We talk about working in partnership with companies, and we don't expect to be the experts in everything that we do. And we have local partners, we call them solution partners, who work with our customers to put systems together, and we work equally with the global system integrators, companies like Capgemini and Accenture. But no, there was clearly a market failure when it came to tech adoption in the UK. We weren't ultimately adopting and deploying technology at scale, and I think the launch of the catapults. They were originally called Technology Innovation Centres, but have, over the last 10 years or so, had the name the catapults to accelerate. Imagine a stone being catapulted quite literally, to speed up the adoption of innovation that would help firms, start and scale or prove product, and then perhaps be able to build industry at scale. And it was modelled on the German Fraunhofer Institute, but it's become a real success story here. Which means that I think we've got these brilliant collaborative models, and they necessitate, they bring together or stand between universities and fundamental research on one end and firms at the other, to really help this technology readiness level of innovation that I think can really help as well.
While we're talking about this, so we talk about technology and how we shouldn't just apply technology, we should be thinking about the problems and the challenges we're trying to solve. So I guess, how do we balance that? There's really great technology out there. I'm going to say predictive maintenance, digital twins, but it's measuring that against like real practical and measurable results for companies as well. So how do we create that balance, Brian, or in your opinion?
Well, technology isn't the first or the immediate answer to every problem, of course, but it may well be that, and this has been my experience of Made Smarter and our experience at Siemens in our factories, like Congleton here in the northwest of England, and that if you've got a clear approach to business process improvement, to thinking about lean, thinking about having the best possible process, that's probably a really good start point for working out that what the problems are you really need to solve. And I think, to go straight for a digital toolkit could mean that you end up with a bit of a poor digital process. So that's the first thing I'd say. But in my experience, I think starting to grow a level of in-house competence really matters. And in Congleton, we gave a team access to technology and space to play with it before going to decide on projects that could be deployed in the factory. So I think starting small and gaining confidence, working with partners was critical. And in our particular case, the journey meant that we moved from perhaps using some robots and understanding what they could do to designing and building an end-of-line pack test robot cell that was enabled us to put 4 of our team members onto other value-adding work, but of course became highly available, highly consistent, as machines can be. On to the confidence to actually design digitally first a whole new manufacturing product line that became paperless, and it helped us to make the transition from building about 500,000 units of essentially a standard product into being able to mass customize, to actually at the point of build have our operators build one of 17,000 variants of a product that the customer had ordered. So you can imagine the ability to go from here's our product, we hope you like it, to here's exactly what you've ordered, means that you've got a real business benefit, and hopefully at not too much delay in terms of design and build. But that's that's been predicated on a journey of building the competence and the confidence to use technology, to move from cardboard box modelling, as we did when thinking about how we wanted to design our spaces, into a computer-aided visual environment, and now into something that's really akin to a digital twin for the factory. So, but you wouldn't start with an advanced program like that. You'd build up to it.
And what's really fascinating about Congruent, and actually Siemens in general, is that we have these sort of factory space. I mean, we talked about earlier how in a way they're sort of a separate sort of like SME, but it's a testing ground for a lot of the technologies we talk about, and that we could also show to potential customers of the future, the technologies in action. I mean, do you agree with that sort of statement and that point of view?
Absolutely. I mean, one of the rather unfortunate expressions I'd heard referred to over the years was eating our own dog food. I'd much rather drink our own champagne. But I think there is an expectation that we are a manufacturer, but we're a manufacturer of, world-leading industrial automation technology. 1 in 3 machines globally features one of our control systems. So there's a real footprint there. And whilst I wouldn't want to imply it's machines making machines, and didn't want to see any parallels with AI in this context, of course we use high levels of automation where we can. We use our own tools and technology. And I think that helps differentiate us, because when our customers come to us, we will talk openly about the manufacturing challenges that we faced, and the role that technology plays in that as well. And I think that's an incredibly important conversation to help upskill and start perhaps investing in the right way. So that there's an awful lot more. I mean, maybe if I just make the additional point that whilst we make electronics, power electronics, instrumentation, a range of technologies, I've always found there's a huge crossover from companies that come in that perhaps make food and beverage products, automotive or aerospace products, but actually they see something in the way that we've deployed technology that often crosses over and becomes very helpful.
And you mentioned actually something else I wanted to cover today, about skills and the importance of skills in terms of adopting technology, because I guess without the skills it's very difficult to understand how technology could be applied to some of those challenges you face. But how do you sort of upskill or start thinking about upskilling the workforce in order to embrace like AI, for example, which is becoming more and more important? Well,
there's 2 routes to that, aren't there? That you recruit and then you retrain, and it's very evident to us that those of us in the workforce today don't have the skills that we will need for the near future, and retraining is becoming much more important for all employers. And that's why we put a target of 50 learning hours per employee in place to make sure that we're doing everything we can with those people we've got to make sure that we keep up. We think about digital dexterity, about AI, about the sort of technologies that are coming down the line, not just digital twins, but actually an industrial metaverse that's in our near and foreseeable future. On the recruiting side, at the early career stage, it's incredibly important for us to play an active role in the design and the deployment of apprenticeship programs, of graduate programs as well. And it's one of the reasons that we've been passionate about partnering with Festo to deliver the connected curriculum program through, I think we're about 14 academic partners now, and there's about 1,500 undergraduates that go through that program per year now. But we recognised we had to go further as a technology company in giving access to up-to-the-minute technologies, computer-aided design software to design, simulate and verify products, automation technology linked to those digital twins so we understand if processes will work, and cloud-based architectures for extracting and exploiting data from industrial processes. And so those students getting access to that sort of digital thread in addition to their core course content has been to us incredibly important. And what we're finding is that those students are having real impact when they go to world of work, and we're doing more to try and find ways to connect that wonderful talent into the firms that need them, because this seems to me to be an area where we've got a critical skills shortage that's reported so often, and this is about building an ecosystem where many people are trained and many companies need them. We've got to find better ways to put them together.
Yeah, so it's almost starting the educational process sort of much sooner. So it's not you get into the workplace and then you learn on the job there. But it's actually starting this much before to, I guess, increase the pool of workers, that can match, these technologies.
And we've got an acute problem in engineering and manufacturing. We've got an image problem, frankly, here in the UK. And some years ago, we ran a project. We called it the Curiosity Project because we found that you had, if you were talking about engineering and manufacturing, you had to sort of get to, kids in schools before you started, with this sense of bias that perhaps kicks in about factories being, as they may have looked in the 1800s, or engineering being somehow dull, and just to think about, be curious about how things work in the world around you, how things are made, and we found that to be quite, successful as an opener to conversations, as a way of sort of channeling, content and curriculum. And today we've built on that in ways that, with our virtual work experience program, for example, that has engaged thousands of young people with us in ways that expose them to, the sort of jobs and careers that are available in firms like ours. And of course, I'm a passionate technologist and an engineer, and there are some incredible job opportunities today. And, for young people looking at, or perhaps passionate about gaming, may well find themselves very attracted to some of the things that we're now doing in, software and simulation, automation and robotics, of course, but solving real world problems with these technologies. So I think we've got to do more to address the image problem. And I think the formation of Skills England under the present government is a really useful step forward, because it recognises the way that we have mismatched supply and demand of skills into the economy. And if you look at the range of, technical and vocational skills that the industry needs, we've got to somehow improve the supply. But if we're to do that, we've got to improve signposting in schools. We've got to better educate parents and students to make better decisions. And I think for firms, we've got to step up and demonstrate, the sorts of roles that are possible. Especially with apprenticeship programs, to earn and learn, but actually reach the same endpoints as many graduate programs. And so I think this is, I know it's a big and gnarly topic, but it's a particularly important one for firms in engineering and manufacturing to step up and, and demonstrate the value in.
No, absolutely. I think that's very clear as well. And if we focus on some of the technologies that are sort of driving this at the moment, particularly, in our sort of remit, or around AI and GenAI, how are you seeing sort of the adoption of those sort of technologies at the moment as they're starting to really emerge, both not just in the industrial landscape, of course, in our own personal lives as well?
No, absolutely. You know as I do that AI, of course, has been around for many years in reality, and for Siemens, actually, in the early 70s, our central research departments were looking at AI and how that could be deployed. So certainly over the last 15 years, and in earnest, we've been working with AI technologies. What happened in the last 2 years was the explosion of AI on a broader stage as a result of large language models. So generative AI that made us feel like we were talking to a human being. And this, of course, when the AI journey started, was called the Turing test. Could a computer imitate a human to the point when the human couldn't tell? And so, the application of AI is, on the one end of the spectrum, it's fun, if we're asking daft questions of ChatGPT, but on the other, it's opening up real value in coding, in access to information, in the sheer efficiency of getting things done, and that's why we're working with technologies like Copilot, for example, in our office environments. But where I'm particularly excited, where we're seeing the really tangible development, if we try and ignore some of the hype, generative AI is helping us in really critical ways with coding. If we've got a shortage of people that can code industrial systems, then getting an AI engine to help code and or check code is incredibly useful, helping us to get to answers earlier in documentation or problem solving in complex systems by asking natural language questions. But equally, I think in this context, a particularly exciting development through our team at Senseye is the introduction of a natural language interface to a condition-based monitoring system. It's unlocking the value wrapped up in data by being able to ask of our systems, why is machine A more available than machine B? Why is machine C consuming more energy? And so AI is going to help us unlock the value in areas that previously needed or necessitated a lot more expertise than will be the case going forward. So I think, for all of us, we've got to consider, how are we going to become experts in using AI in order to make more progress earlier? And, I think Siemens' job in this is to deploy systems that are absolutely fit for use and derived from, the most credible source data that helps us accelerate the sort of outcomes we're looking for in industry: productivity, sustainability, resilience, outcomes that technology can help with.
Yeah, and I could talk from a sort of a Senseye perspective as well, but that evolution. So everyone is obviously excited by interactive Copilot. We can ask questions and go back and forth, and it's incredibly powerful. But actually, one of the biggest innovations was a step before that, where you could open a case, notifying a maintenance team that there was an issue to be investigated, and instead of having to maybe try and interpret what it was, there's now a natural language automatically there, bullet pointed, and these possible corrective actions that you should take, and that's in seconds. And anyone, and what's impressive for me is it makes it accessible to anyone. It's not just even someone like me. I'd say someone who's not technically savvy, but even I could log in and understand straight away, and that's just very powerful, isn't it?
It absolutely is. And if the sort of applications I've seen, in our factories, we've been able to understand in Amberg the antecedents to a failure of some of the cutting machines for our PCBs there, the printed circuit boards. So being able to change machines or do maintenance prior to a failure that stops a shift loss of production downtime. We've applied AI broadly into applications like the water industry. We're working with Yorkshire Water and Sheffield University. We've been able to predict flooding incidents prior to them happening, and based on sort of historical rainfall data, but 9 out of 10 incidents predicted from data. So I think we're gaining, the confidence and the use cases to demonstrate where data, when, exposed to the right algorithms like Senseye, can add tremendous value. And it's not just to avoid failure, but actually in some cases to help companies maintain less. They might be over maintaining a factory, a series of machines. And if that means, not switching off or not taking the lines down because you can extend, maintenance, particularly for mechanical components, then that equally becomes a saving. So I think, there's some real power in data. And I love the way that, our Senseye technologies are really helping to unlock that for companies at scale.
Yeah, so thank you, Brian. I know we've been very generous with your time, and thank you again for sort of sharing your insights with our audience. I just wanted to end, because we were talking about AI and GenAI again, and it's sort of this future look at technology and where you're seeing we've talked about, actually maybe people adopting technology, but if we're talking about, the future and really what's upcoming in your mind in terms of technologies which are going to really change manufacturers moving forward.
The metaverse it will be always on, it will be persistent, it will be collaborative, it will be real time. In many cases it will be photorealistic, but immersive in the sense that we will be able to build incredible approximations of the real world in infrastructure and industry, and use that to make things better. And Roland outlined, some of that potential in his presentation at CES. But of the potential for the metaverse, which is enhanced meetings, it's gaming, and it's industry, I think the analysts now are, all predicting that the greatest use of that environment will be in industry. It is the ultimate use of data at scale to help companies and countries make better decisions. So that's one I'd certainly be reading up on.
Yeah, no, very interesting. And I remember the presentation myself. I remember watching it myself. It was, it was really, really good. So I think what we could do is sort of link to that in the show notes as well, so people can access that quite easily. But no, for today, I think we've covered a wide range of topics. It's been really fascinating, Brian. So thank you again for taking the time to speak to us today and for sharing your insights. And thank you everyone for listening and watching at home or wherever you are. And we'll see you on the next episode.
My pleasure. Thank you very much.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.